Hello, good day everyone. Once again, welcome to my channel. This is Engineer Reagan. Um, a few days ago, I taught you how to solve quadratic equation by doing the completing the square technique, right? But then in response to one of my students' question on how to solve quadratic equation by doing completing the square when the a coefficient is greater than 1. Because in my previous examples, the previous video, it only showed quadratic equations with a coefficient equals to 1. But this time, I'm going to show you how to solve completing the square when its a coefficient is greater than 1. When I say a coefficient, it is actually the constant coefficient of the variable that is raised to the power of 2. Okay, so for example, if you have 3x squared, the x squared there is the variable with the higher form, and your 3 becomes your a coefficient. So for you to really grasp what I'm really talking about, so let's move on to our example. We have here 3x squared minus 12x equals to 9. The a coefficient is 3. Why is it 3? Because when we talk about the a coefficient, once again, it is actually the constant beside the variable x squared. Okay, so in this case, 3 is the a coefficient. Okay, so what will we do then, by the way? Okay, the first thing to do is actually to get rid of the 3. And for us to do that, we just have to divide each term by that coefficient. Easy as that. Divide it by 3, divide this one by 3, also the 9 divided by 3. So 3 over 3, that cancels out. So all you have left actually is x squared minus 4x is equals to 3, right? Okay. So after this point here, I know that we're already pretty much familiar with the process. Okay, so the next thing to do is now we will be going through the technique of completing the square. And to do that, you just have to make a third term out of this one. How? We divide the coefficient of the second term. And in this case, it's 4. That's the coefficient of the second term. Do we divide it by 2? And then raise it all together to the power of 2. That's it. And then 3 plus 4 over 2 squared. Okay, why did we add exactly the same amount coming from the left equation? Because according to mathematics, whatever you added or you subtracted from the left side of the equation must also be done to the other side of the equation. And we do that so as not to change the value. Okay, what we're actually trying to do is we will just be changing the form. Okay, so what will happen now? This becomes x squared minus 4x plus 4 over 2, that's 2, raised to the power of 2, that's 4. 3 plus 4. Okay, now look at the left side of the equation. We now have formed into a perfect trinomial square, meaning if you factor them out, what you will get is perfectly the same factors, 2 perfectly the same factors. So x squared minus 4x plus 4, when you factor them out, you will get this, x minus 2 times x minus 2 is equals to 7. So x minus 2 times x minus 2, it's the same as x minus 2 squared is equals to 7. That's it. Now, the next thing to do is we will solve for x, but before we can even solve for x, we need to get rid of the 2 here, the square. How to do that? By getting the square root of both sides. So you will now have square root of x minus 2 squared is x minus 2 is equals to positive minus square root of 7. Why positive and minus? Why? Because when you get the square root of a number, you always need to consider both the positive and the negative sign of that number. Okay, so what we have left is actually just the process of solving the 2 values of x this time. So you have x minus 2 is equals to positive square root of 7, and x minus 2 is equals to negative square root of 7. So your values for x here, in this case, is x 2 plus square root of 7 and x equals to 2 minus the square root of 7. These are your two values of x. Okay? If you want, you may get the specific value of square root of 7 by solving it in your calculator. Because actually we can no longer simplify this one because square root of 7 is a perfect square root. You may, as I've said, you may express this into a decimal answer, but then as for me, this is already sufficient. Okay. Pretty quickly, let's move on to our second example. Okay, 2r squared plus r equals 3. This example actually is pretty much the same with the last one that we have. Only then that our a coefficient is 2 in this case. Okay, so what shall we do? Again, we divide each of the terms, okay, by that coefficient. And in this example, it's the a is 2, so we divide each by 2. So 2 over 2, that one cancels out. All you have left is r squared plus 1/2 r is equals to 3/2. Okay? So right after here, we will do the completing the square. And we know that by completing the square, we need to make a third term. The third term is this. We just need to divide the coefficient of the second term, and the coefficient of the second term in this example is 1/2. So divide 1/2 by 2, and then altogether raise it to the power of 2. Okay, so 3/2 plus 1/2 all over 2, raise it to the power of 2. Easy, right? And then r squared plus 1/2 r 1/2 over 2, that is 1/4 to the power of 2. So that's 3/2 plus 1/4 to the power of 2. Okay? That becomes, let's simplify this, r power of 2 plus 1/2 r plus 1/4 to the power of 2 is 1 over 16 is equals to 3/2 plus 1 over 16. Okay? Now again, what we have formed from the left side of the equation is a perfect trinomial square, meaning that when you factor them out, you will get to perfectly the same factors. That's why it's called perfect trinomial square. So r squared plus 1/2 r plus 116, you will get a factor or factors out of that equation, out of that expression into x plus 1/4 and x plus 1/4 is equals to. Okay, you have 3/2 plus 16. In this case, you are adding two fractions with two different denominators. And to do that, going back to our basic mathematics, we need to get an LCD, the least common denominator. And the least common denominator in this example is 16. So 16 divided by 2, that's 8. Multiply it to the numerator times 3, that's 24. So it becomes 24. Then plus 16 divided by 16, that's 1 times 1. Again, that's 1. Okay? So x plus 1/4 times x plus 1/4, that becomes x plus 1/4 squared. And then 24 plus 1, that becomes 25 over 16. Okay? So we now have simplified already our equation. The next thing to do, to get rid of the square here, we will have to get the square root of both sides. So this now becomes x plus 1/4 is equals to, again, plus and minus what? Square root of 25 is 5. Square root of 16 is 4. By the way, I'm sorry, I got mixed up. Why did I even call the variable here as an x? No, this is not an x. I'm sorry. Okay, this is r. Okay, I don't want you to be confused about it. I just got mixed up, so this is not x actually. The variable we're talking about here is r. So this one's r. Okay, so that's r plus 1/4 is equals to positive negative 5/4. So this time we will solve for the values of r. So you have r plus 1/4 is equals to 5/4 and r plus 1 r plus 1/4 is equals to negative 5/4. Okay, when you transpose, plus 1/4 becomes now negative 1/4 plus 5/4. So negative 1/4 plus 5, you'll have 4. So 4/4, that's 1. That's the value of r. And here you have negative 1/4 minus 5/4. Negative 1 minus 5, you have negative 6/4. Or, okay, turn this into a lowest term. Both are divisible by 2. This becomes negative 3/2. So these are your two values of r. R equals to 1 and r equals to negative 3/2. Okay, that's it. I believe on and I guess I was already able to cover much about the completing the square, and I hope I was able to help you out, guys. But then if you need any more help, just please let me know which part of the entire process that you want to go more about. Just please leave your comments below and tell me about it, or let me allow me to take this opportunity to invite you. If you want to be updated about the next videos that I will be uploading in the coming days, please subscribe to my channel. Okay, so that's all for today. God bless everyone.